Can you imagine a day without water to drink? We almost always have access to safe drinking water. Within 15 years, 2.6 billion people have gained access to improved drinking water source. However, in reality, 783 million people still do not have access to clean and safe water worldwide. Hence, we focused our project topic on the area of portable water purifier, targeting the problems with lack of access to safe drinking water in the developing countries. United Nations General Assembly recognized the right of every human being to have access to sufficient water for personal and domestic uses, which must be safe, acceptable, affordable, and physically accessible. There are various problems associated with poor drinking water conditions. One of the biggest problems is the spread of waterborne diseases caused by pathogenic microbes. Waterborne diarrheal disease is the most prominent example, mainly affecting the children in developing countries. Nearly 1 out of every 5 deaths under the age of 5 is due to the water-related diseases. Spread of germs in contaminated water can cause diseases such as cholera, typhoid, and polio. For instance, guinea worm disease is an extremely painful parasitic infection spread through contaminated drinking water. Clean water crisis also has a negative social impact. Women and girls often spend up to 6 hours each day collecting water, meaning that they need to make long and risky journey, making themselves prone to sexual harassment and rape. Also, children suffering from water-related diseases are unable to attend school. In fact, 443 million school days are lost each year due to water-related diseases. Due to poor health, people are not able to work, which leads to the decrease in income. The decrease in income then limits people's access to safe drinking water, and this again leads to poor health. Therefore, access to clean drinking water not only gives health benefits, but also both social and economic benefits. By being able to purify nearby water source, people spend less time and effort in physically collecting it, meaning they can be productive in other ways. It also increases personal safety as it reduces the need to travel far to collect water. It is estimated that improvement of drinking water quality can lead to a 45% reduction of diarrhea episodes. Better drinking water quality would mean less expenditure on health, as people are less likely to fall ill and incur medical costs, which will lead to higher standard of their lives. According to water.org, every dollar invested in water and sanitation provides $4 of economic return. With children, particularly at risk from water-related diseases, access to improved sources of water can result in better health and therefore better school attendance, which creates longer-term benefits for their lives and society they live in. In order to propose a solution to this problem, we researched about existing water purifiers that use different techniques. First example is GROUP13, which is a water purifying solution. By adding few drops of this solution, its active ingredient, chlorine dioxide, eliminates harmful parasites, pathogens such as E. coli and Salmonella. It's a quick and simple method of chemical treatment, and one small bottle of solution can treat up to 250 liters of water. However, there is no physical filtration involved, hence, it cannot remove solid contaminants. Second existing drinking water purifier is Viqua ultraviolet lamp. Ultraviolet light eliminates microorganisms in water, but it does not remove any other contaminants, such as heavy metals and petroleum products. Also, water has to be clear as rays cannot be blocked by other particles, and it is very expensive, that single product costing over $100. Lastly, Life Straw, consisting of two main components: activated carbon capsule and hollow fiber filter that use physical filtration to remove chemicals, pesticides, and pathogens. It is lightweight, easy to use, and able to clean up to 700 liters of water. If we assume that the daily water consumption of a person is 2 liters, then the lifespan of it will be nearly 1 year long. Also, the bottle design seems the most appropriate to serve the purpose of it being portable. However, this product also has some limitations. 0.2 microns fibers cannot filter virus. The shape of the bottle is not appropriate for infants to use, even though they are the ones who need clean water the most. It cannot remove salt and heavy metals. Therefore, we decided to make our own product by combining Life Straw and graphene nanotube to overcome those limitations. We aim to keep the advantages and compensate the disadvantages through innovative changes. Our product is a portable water bottle that can purify water as the user sucks on the plastic mouthpiece. As a purification takes place immediately, it is user-friendly, meaning that it is quick and easy to use. The bottle is 5 inches long with 1 inch diameter. We changed the shape of the bottle to make it more suitable for infants and young children to use. For example, the curved shape allows them to get a better grip of the bottle. The filtration process can be broken down into 3 main parts. First, the graphene nanotube is our innovative element, which can filter heavy metals such as cadmium, mercury, nickel, and others for 99%. So how is this made, and what is the mechanism behind absorbing heavy metals? A thin film of multi-walled carbon nanotubes, which contain many single-walled carbon, is deposited on quartz wool, which is highly resilient, chemically inert, and porous. Multi-walled carbon nanotube itself is produced by chemical vapor deposition of hydrocarbons along with the metal catalyst. Chemical vapor deposition of ethylene using metal catalysts such as iron, cobalt, and nickel can produce the thin films of multi-walled carbon nanotubes. Carbon nanotube surfaces can be either covalently or non-covalently functionalized to achieve highly desirable surface properties. Epoxidation is one form of covalent functionalization that occurs in multi-walled carbon nanotubes. It adds an epoxide group to the surface carbons in multi-walled carbon nanotubes such that for every 2 carbon atoms there is 1 oxygen atom. These oxygen atoms have lone electron pairs, and these electron pairs let the oxygen atoms act as ideal Lewis bases, which are the electron pair donors. Since Lewis acid-base interactions facilitate in the facile formation of chemical complexes upon rehydration of the empty orbitals, epoxidized multi-walled carbon nanotubes have great potential for heavy metal absorption. Second component is the hollow fiber membrane, which is produced by using artificial polymers. 0.02 micron pores on the membranes reduces turbidity and filter out about 99% of bacteria, such as Salmonella and cholera, and as well as the viruses. Another advantage of graphene nanotube is that it can be easily cleaned with vinegar and reused without replacement. Absorbed heavy metals can be washed off from multi-walled carbon nanotubes without changing the epoxide groups through cleansing with acidic solutions such as vinegar. Low pH of the solution induces a positive external surface charge from protons and functional epoxide groups. Hence, between the functional epoxide groups of multi-walled carbon nanotube films and the heavy metal cations, an electrostatic repulsion force will be formed. This property of graphene nanotube filter lets itself to become reusable filter. Last element of purifier is the capsule filled with powdered activated carbon, which is responsible for eliminating chemicals and pesticides such as trihalomethanes and polychlorinated biphenyls. Activated carbon is composed of expanded layers of graphite, which leads to an extremely high surface area to mass ratio for absorption of contaminants. Hence, the contaminants with high binding affinities from activated carbon are absorbed effectively. But where can we obtain activated carbon? Activated carbon can be extracted from dried moringa seed pods and husks through single-step steam pyrolysis activation. Pyrolysis is a process of heating organic material at high temperatures in the absence of oxygen. So heating moringa seed pods and husks in a steam atmosphere to 800 degrees Celsius for 3 minutes produces carbonized material, the activated carbon. Activated carbon from moringa can be acquired at a very low cost because the pods and husks used are byproducts of crude oil production from moringa. Thus, people who cultivate and process moringa can also make profit from selling crude oil as well as selling activated carbon. To exemplify and model the social and economic benefit that our portable water purifier production can bring, the following statistics from Zambia will be used. According to UNICEF, in Zambia, 4.8 million people are living without access to safe drinking water, which is about 30% of the total population. If we base our calculation on that on average, one person needs 2.5 liters of clean water per day, and our purifier can filter 1,000 liters. In other words, one person can use a product about a year without making any replacements of different filtration parts. And 43.75 grams of moringa seed is required to make one activated carbon capsule. We need about 210 tons of moringa seeds per year to produce 4.8 million purifiers. Currently, 4 hectares of moringa seed farm in Zambia produces 19,000 tons of seeds per year, which is 90 times more than we need. Hence, using these seeds, we can make more than enough activated carbon capsules to be used in purifier production that will allow all local people to have access to clean water. The production cost for each product is about $25, $5 per activated carbon capsule and hollow fiber, $20 for one nanotube filter, 2.5 cents for water bottle itself. At first, the production cost can sound very expensive. However, it can be compensated by selling moringa seed to the market. Selling 1 kilogram of moringa seeds makes $27 profit. Therefore, calculating the total money made by selling excess moringa seeds and subtracting production cost, approximately $390 million of annual profit can be made. In other words, there is $24.2 annual profit per person. To sum up, some advantages of our water purifier are filter 99% of bacteria, virus, and heavy metals. Lightweight, portable, time efficient. No electricity is required. It's powered by user-generated suction, made of durable plastic. Works for turbid water. It's chemical-free. It doesn't use chemicals for purification, such as iodine or iodine resin. It can filter 1,000 liters of liquids. One product can last about a year for a person. No need to get a new graphene nanotube, reusable and last a lifetime. On the other hand, the disadvantages are User must replace the activated carbon capsule and hollow fiber filter after expiry date. It cannot remove salt, hence, it cannot purify seawater. It cannot filter out virus that are smaller than 0.02 microns. However, the overall advantages outweigh its disadvantages. Hence, our portable water purifier is suitable to use in developing countries on a daily basis.